Hello and good evening, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to GATE Conqueror channel. I welcome you all to my session of EM Wave Propagation. This is going to be a very important session, dear. Ask all of your friends to join very soon. In EM Wave Propagation, we are into pointing theorem and wave polarization. It is session number 8 of this particular series of EM wave propagation from subject of EMFT, and this is module 2. Of EMFT. Before we do that, let me introduce myself. I am Chaitanya Reddy, having 15 plus years of experience in teaching, guiding and mentoring GATE and ESE aspirants. I've been working as motivation speaker pan-India from the past 12 years, an expert in field theory and communications. Just kindly confirm the video and audio once, dear. Is the video and audio clear? Before we start the class, let me introduce our Telegram channel. And this is the link for the official Telegram channel. We can access all the GATE Conqueror faculties, including the legendary K.N. Rao sir. So if you want a personal level assistance from all the GATE Conqueror team, you can join us. This is the link, dear. After this class, take a screenshot. After this class, you can use this link to join us on Telegram. So we are into EMFT. We completed module 1 of EMFT, which is elements of EMF theory. Which is complete syllabus. Which is the complete syllabus for electrical students. And module 1 for EC students. We completed elements of EMF theory. We completed all the derivations, theory, previous year questions and practice questions, so that this will be useful for GATE and ESE as well as other competitive exams. Also useful for other competitive exams. We'll finish this elements of EMF theory. Module 1, we created a playlist for the same, which includes 40 videos and 50 hours. Mostly in any YouTube platform, if you check, at a max, we get 10 to 12 hours of concept based on elements of EMF theory. Against that, we have recorded 50 hours of content only for elements of EMF theory. I can very surely say that you cannot find content more exclusively than this. This playlist is available. This playlist is available, dear. Just try and confirm the video and audio once. I request everyone to confirm the video and audio once. I request everyone to confirm the video and audio once. Just I want to make sure that the video and audio is clear, then we can continue. Just confirm the video and audio once. Just a second here. Just checking for the connectivity. Just trying to check for the connectivity here. Just 1 second here, 1 second, 1 second. Just a second. Okay, you can go through these 40 videos, 50 hours of duration, where we'll cover complete elements of EMF theory, where we cover static field theory. Under static field theory, we confirm or we cover electrostatics, and magnetostatics. Electrostatics and magnetostatics put together is called as static field theory. Okay. Good evening, Jansi. Just confirm the video and audio, dear, once. On my phone, I am not able to receive any comments. It's not visible. Is my picture not visible? Jansi, please confirm once. Well, fine. Just confirm once, dear. Now, dear. Jansi, now confirmed, dear. Refresh once. Because what I can see in my preview, is I can see the video and audio. I can see in the preview, dear, the video and audio. Just I want to confirm from you people. I'm not sure. One second, let me get the confirmation. Let me get the confirmation, dear. Not able to receive any messages. That's the problem. One second, just confirm once. Okay. Okay, thank you, thank you. One second, yes. Fine, thank you. Sorry for the delay. Just I want to make sure that because Jansi was telling that the video is not clear. There I got struck. Okay. Okay, thank you everyone. Thank you. So in static field theory, we covered electrostatics and magnetostatics. In static field theory, we derived Maxwell equations, for static fields, in which we derived Maxwell first equation, closed surface integral of d dot ds is equal to volume integral of rho v dv, integral form, differential form, del dot d is equal to rho v, source, Gauss law for electric fields. Okay, thank you. Then the second equation, okay, Sadish sir, thank you. Closed loop integral of E dot dl is equal to 0. differential form del cross E is equal to 0. Source conservative property of electric field. Third equation, closed loop integral of H dot dl is equal to surface integral of J dot ds. You get del cross H is equal to J. Source Ampere's law. Fourth equation, closed surface integral of B dot ds is 0. Differential form del dot B is equal to 0. Source, non-existence of magnetic monopole, also called as Gauss law for magnetic fields, also called as Gauss law for magnetic fields. These are Maxwell equations for static fields we have derived. Besides this, we are also derived Laplace and Poisson's equations. We derived boundary conditions. And also we derived the derivation for different types of capacitances and inductances, which completed static field theory. And also we went through time varying field theory, where we have derived Maxwell equations for time varying fields, in which mainly we had went through Faraday's law, and inconsistency of Ampere's law. Faraday's law and inconsistency of Ampere's law. From Faraday's law, we modified this equation from Faraday's law, and from inconsistency of Ampere's law, also called as Maxwell contribution, we modified the third equation. After modifying, the first and fourth equations are same, second and third are modified. The modified equations are closed loop integral of E dot dl is equal to surface integral of minus dou B by dou T dot ds. Del cross E is equal to minus dou B by dou T. Faraday's law. Maxwell contribution, closed loop integral of H dot dl is equal to surface integral of J plus JD dot ds, where J is conduction current density sigma E, JD is dou D by dou T, displacement current density. Differential form del cross H is equal to J plus JD. As usual, J is conduction current density and JD is displacement current density. Good evening. Raj, good evening. Anil, good evening. Fine. Okay. Now, this is what we had covered in module 1. Still, I will add up some more ESC derivations and practice questions later on. Right now, you can find some 50 hours of content with 40 videos. in this exclusive series. Then we are also covered module 5, antennas. Actually, it is antennas and optical fiber communication. I will cover optical fiber communication separately. I will try to cover this separately in a different series. Antennas I had covered the series name Antennas Mahamarathon series, where we had covered exact number, let me tell you. We had covered 18 parts in this, covering around 37 hours of lecture, which covered complete antennas and wave propagation. You can just go through the Antennas Mahamarathon series. You will find what all topics we had covered. But I can say one thing, dear, again, you cannot find any series more exclusively than this on antennas. Generally, on antennas, they will take 5 to 6 hours. But we took 37 hours of lecture on antennas, covering all the concepts of antennas and wave propagation, useful for GATE and engineering services. I'll add up 100 to 200 practice questions to this. I'll add up Antennas Mahamarathon 19 and 20 very soon, where I'll add up some previous year questions which are missed out, plus 100 to 200 practice questions. This will add up soon. This series, we are into module 2. Module 2 of EMFT is EM Wave Propagation. In EM Wave Propagation, we have covered EM Wave Propagation in free space. It is epsilon r is 1, mu r is 1, sigma is 0. Covered EM wave propagation in materials. Epsilon r is greater than 1, mu r is greater than 1, sigma not equal to 0. Also covered EM wave propagation in good conductors. Sigma is far greater than omega epsilon. EM wave propagation in good dielectrics. Sigma is far less than omega epsilon. It also were covered EM wave propagation in perfect dielectrics. Perfect dielectrics is a case where sigma is 0, epsilon r is greater than 1 and mu r is greater than 1. We had covered up to these topics. What we need to cover is pointing theorem, wave polarization, reflection and refraction of plane waves. This we need to cover. And in today's class, mostly try and cover these topics of EM wave propagation. Any doubts you can ask here. Some very important concepts I am going to deal. Any doubts you can ask. Just checking for the doubts. Any doubts you can ask here. Yes. Any doubts? Any doubts, you please ask me. Okay. So now we'll go for the comparison of different parameters when the waves are propagating through free space, through materials, through good conductors, through good dielectrics and perfect dielectrics. Let us compare here. Comparison, starting with free space, perfect dielectric, good dielectric, good conductor, and perfect conductor. Let us start our discussion with conductivity. In free space, conductivity sigma is 0. In perfect dielectric, there won't be any conductivity, sigma 0. In good dielectric, you'll have less conductivity. Good conductor, you have more conductivity. In perfect conductor, conductivity is infinity. So conductivity is having the journey from 0 to infinity as it is moving from free space to perfect conductor. Next, alpha, no attenuation in free space, no attenuation in perfect dielectric. Alpha, attenuation very less in good dielectric. Is sigma by 2 into under root of mu by epsilon. As sigma is less, alpha is also less. For good conductor, alpha under root of omega mu sigma by 2. As sigma is high, alpha is also high. indicating that the wave attenuates more in a good conductor. That means when an EM wave is propagating through an iron log, it attenuates more when compared to EM wave propagating through a wood log. So that's the understanding you should have. And here sigma is infinity, alpha is also infinity. In perfect conductor, you will have infinite attenuation. Therefore, wave cannot exist in perfect conductor. Next, the value of beta for free space, it is omega into under root of mu naught epsilon naught. Perfect director is omega into under root of mu epsilon, where here mu r is greater than 1, epsilon r is greater than 1. Therefore, beta value slightly increased. Here, for a good dielectric, beta is equal to omega into under root of mu epsilon plus 1 plus sigma square by 8 omega square epsilon square. Good dielectric has small value of sigma value. Therefore, beta increases when compared to perfect dielectric. In good conductor, beta is under root of omega mu sigma by 2. Sigma is a very large value. Therefore, beta is also very large. And for perfect conductor, it is infinity. Now again, this is a journey of beta from free space to perfect conductor. Here it is least and here it is the highest. So those are the values of beta. Then the velocity, which is given by the omega by beta, is 1 by under root of mu naught epsilon naught, which is velocity of light 3 into 10 power 8 meter per second. Next, velocity omega by beta is 1 by under root of mu epsilon, which is c by under root of mu r epsilon r. As mu r is greater than 1 and epsilon r is greater than 1, velocity v will be less than c in perfect dielectric. Velocity is 1 by under root mu epsilon 1 minus sigma square by 8 omega square epsilon square. As you can see here very clearly, the velocity is decreasing. Here velocity is c, highest. Then it has decreased, then still decreased. There is a minus here, still decreased. Under root of 2 omega by mu sigma. Velocity here is under root of 2 omega by mu sigma. Sigma is very large value, so velocity is still decreasing. Here sigma is infinity, velocity is 0. So from highest to 0. In perfect conductor, the wave cannot propagate. That's why its velocity is 0. Eta value, intrinsic impedance, under root of mu naught by epsilon naught, which is 120 pi or 377 ohm. Eta value under root of mu by epsilon 120 pi into under root of mu r by epsilon r. In most of the practical cases, mu r is equal to 1, epsilon r is greater than 1. Therefore, eta is starting to decrease, and moreover, eta is pure resistance in these cases. In both these cases, it is pure resistance. Remember that whenever sigma is 0, impedance is pure resistance. You don't have any losses. You will not have any losses. Now, for good dielectric, eta is under root of mu by epsilon 1 plus j times of sigma by 2 omega epsilon. It is imaginary nature, and here eta is under root of omega mu by 2 sigma plus j times of under root of omega mu by 2 sigma. Here eta is 0 because wave does not exist. In both these cases, we have reactance component because sigma is not equal to 0. Because sigma is not equal to 0. So this is the analysis, dear. Any doubts in the analysis, please let me know. Any doubt in the analysis, please let me know, dear. Clear? Next is pointing theorem. Next is pointing theorem. Pointing theorem will give you the power associated with a given wave. Pointing theorem will give you power associated with a given wave. The derivation for pointing theorem. The derivation for pointing theorem. From inconsistency of Ampere's law, or from Maxwell contribution, del cross H is equal to J plus JD, where J is conduction current density, just sigma E depends on conductivity of the material. JD is displacement current density, depends on time varying field, given by dou D by dou T. D is equal to epsilon E. Substituting. Del cross H is equal to sigma E plus epsilon times of dou E by dou T. If you see this expression carefully, curl of H is equal to sum of conduction current density and displacement current density. The sum of conduction current density and displacement current density must be one more current density. Therefore, each term in this expression is having unit of current density, which is ampere per meter square. But by definition, you know that pointing theorem will give you something related to power. If you want to convert this into power, you need to multiply it with this with volt per meter. Then it will be converted into power per meter cube. Power per unit volume. So what is the quantity which is having volt per meter here? Please tell me. Which quantity will have volt per meter? Please let me know. Which quantity is having volt per meter? Let me know. Which quantity is having unit volt per meter? Please let me know. Electric field intensity. E is having unit volt per meter. So multiplying the complete equation by E, del is a vector, H is a vector, cross product of any two vectors is a vector, so dot E, del cross H dot E is equal to sigma E dot E, epsilon E dot dou E by dou T. If you can see here, one side multiplied with E, complete equation is converted into power per unit volume. Converted into power per unit volume. Now, applying the vector identity del dot A cross B is equal to B dot del cross A minus A dot del cross B. Del dot A cross B is equal to B dot del cross A minus A dot del cross B. Substituting. Del dot E cross H is equal to H dot del cross E minus E dot del cross H. H dot del cross E minus E dot del cross H. From this, as you know, dot product obeys commutative. A dot B is equal to B dot A. Therefore, we can write E dot del cross H as del cross H dot E. Taking this onto the other side. Taking this onto the other side. E dot del cross H, which is equal to del cross H dot E, both are same, is equal to H dot del cross E minus del dot E cross H. Now we got this. Substituting del cross H dot E is H dot del cross E minus del dot E cross H is equal to sigma E dot E square plus epsilon E dot dou E by dou T. But we know from Faraday's law del cross E is equal to minus dou B by dou T. Substituting H dot minus dou B by dou T minus del dot E cross H is equal to sigma E square epsilon E dot dou E by dou T. You can write B as mu H. So this is B is mu H minus mu H dot dou H by dou T, bringing this minus epsilon E dot dou E by dou T minus del dot E cross H is equal to sigma E square. Solving this, H dot dou H by dou T can be written as H into dou H by dou T, which can be written as 1 by 2 dou by dou T of H square. Similarly, E dot dou E by dou T can be written as E into dou E by dou T, which can be written as 1 by 2 dou by dou T of E square. Substituting, this is minus mu by 2 dou by dou T of H square minus epsilon by 2 dou by dou T of E square minus del dot E cross H is equal to sigma E square. Remember, each term here represents power per unit volume. Each term represents power per unit volume. Therefore, we can write sigma E square just a second here. Was it out here? Okay. Sigma E square is equal to minus dou by dou T of 1 by 2 mu H square 1 by 2 epsilon E square minus del dot E cross H. Now, each term here represents power per unit volume. If you integrate it or volume integral of del square volume integral of sigma E square dV is equal to minus dou by dou T of volume integral of 1 by 2 mu H square 1 by 2 epsilon E square of dV minus volume integral of del dot E cross H of dV. Now, very clearly that each term here is representing power. Okay. Let me write it here. Volume integral of sigma E square dV is equal to minus dou by dou T of volume integral of 1 by 2 epsilon E square 1 by 2 mu H square of dV minus volume integral of del dot E cross H of dV. Volume integral of sigma E square of dV is equal to minus dou by dou T of volume integral of 1 by 2 epsilon E square plus 1 by 2 mu H square dV minus volume integral of del dot E cross H of dV. Solve it here. Just solve it. Harshad, how are you? How are you, my dear? Electric field, correct. So if you see here, each term here represents power. If you drop the analogy, what does it represent here? This is power dissipated. Yeah, please let me know. Power dissipated due to I square R losses or conduction losses, due to I square R losses or conduction losses is equal to, I repeat it, power dissipated due to I square R losses or conduction losses is equal to, this is 1 by 2 epsilon E square, energy density in electric field 1 by 2 mu H square, energy density in magnetic field. This plus this is total energy density. Volume integral of energy density is work done. Dou by dou T is change in work done minus dou by dou T, rate of decrease of work done or stored energy. Therefore, I can say that power dissipated due to I square R losses or conduction losses is equal to rate of decrease of total stored energy, minus what you got here, volume integral of del dot E cross H dV. Now if you see here, volume integral of del dot E is a vector, H is a vector, E cross H dot dV. Let E cross H is one more vector A. This is of the form volume integral of del dot A dV, divergence theorem, which is equal to surface integral of A dot ds. So replacing this equation, volume integral of minus volume integral of del dot E cross H dV is equal to volume integral of del dot A dV, which is surface integral of A dot ds, that is del cross H dot ds. Now, according to conservative property of energy, can you tell me what must be the last term? Anyone? According to conservative property of energy, can anyone tell me what should be the last term? Anyone? Harshad, Raj, Anil, Ravindra, anyone? What must be the last term? What must be the last term? According to conservative property of energy, the amount of power dissipated due to I square R losses is equal to rate of decrease of stored energy plus what? Plus some incoming power. Plus some incoming power. For example, this is power dissipated due to I square R losses or conduction losses. For example, you are using your cell phone continuously. So what happens? The power dissipates or current will pass through the motherboard. Then the charging will decrease. The amount of power dissipated due to I square R losses or conduction losses is equal to how much? The amount of current that is passing through this motherboard is how much? Is equal to the rate of decrease of the stored energy in the battery. If you use your cell phone more continuously, more current will pass through the motherboard, more charge will decrease. For example, you are attending very important class. Of course, it does not happen in that way. But if you are attending any important class and you don't want to miss the class, your charging is down, the charging of your cell phone is down, but you still want to attend the class, what you will do? Immediately you try to plug in plus incoming power. That is from conservative property of energy. From conservative property of energy, the last term must be incoming power. So from this, incoming power is minus surface integral of E cross H dot ds. The outgoing power is positive surface integral of E cross H dot ds. If this is power which is equal to surface integral of something, then what should be this something, dear? Anyone? Surface integral of something is giving you power. Then can you tell me what is that something refers? Surface integral of something is giving you power. Can you tell me what is that something refers to? What is that something refers to? Surface integral of something is power, then this something must be power density. Power density is nothing but power per unit area. In surface integral of ds is area. Area and area get cancelled, you get power. So power per unit area, therefore that must be power density. Therefore I can say E cross H refers power density at any given point. E cross H refers to power density at any given point. Therefore, from this we can write that power density is given by P is equal to E cross H. This P is called instantaneous pointing vector. This P is called as instantaneous pointing vector. Analogy. Analogy for this, W sinusoidal is equal to V sinusoidal into I sinusoidal. From this, complex Poynting vector is given as 1 by 2 E cross H conjugate, where E and H are phasor components. 1 by 2 E cross H conjugate gives you complex Poynting vector. Analogy, complex power is 1 by 2 V into I conjugate. In this, if you take the real part, 1 by 2 real part of E cross H conjugate is the real power, the real Poynting vector or average Poynting vector is called as the real Poynting vector average Poynting vector. Real Poynting vector or average Poynting vector. Clear? It's given by P average. This is P complex. Here W average 1 by 2 real part of V into I conjugate. Similarly, average power or real power, imaginary Poynting vector or reactive Poynting vector is given by 1 by 2 imaginary part of E cross H conjugate. This refers to imaginary Poynting vector, reactive Poynting vector. Here W reactive is 1 by 2 imaginary part of V into I conjugate. This is the analogy here. And for most of the cases, the power that we utilize or consider for practical cases is the average power or the real power. Average Poynting vector, real Poynting vector is given as 1 by 2 real part of E cross H conjugate. From this, average Poynting vector can be given as 1 by 2 mod E mod H, angle between E and H 90, sin 90. From this we get average Poynting vector value is 1 by 2 mod E mod H. But we know that ratio of E to H is eta, intrinsic impedance. Thereby, if you want, this is average Poynting vector in terms of both E and H. If you want only in terms of E or only in terms of H, we can do one thing. From this we can write H is equal to mod E by eta. This P average is 1 by 2 E square by eta. And from this we can write E is eta H. Substituting P average is equal to 1 by 2 eta H square. These are the formulas for average Poynting vector. Is it clear? Yeah. Please let me know, dear. Is that clear? Clear? We'll do the numerics of pointing theorem in the next session. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly test, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, you'll have all these features. Along with that, you have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts within 1 hour, preparatory study material, personalized test analysis, study booster sessions, and customized study planner. You're going for Plus subscription or an Iconic subscription, I recommend you to go for a no-cost EMI, where total cost will be divided by number of months without having any extra charges. Very much student-friendly, dear. That will be very much suitable, and you can use our team code KNR10. The speciality of the team code is you will get, not only that you will get 10% off, but also you will get complete team support. This is a unique feature of this particular code KNR10. This is on behalf of the complete GATE Conqueror team. Iconic subscription, you will get 1:1 live mentoring, increasing your chance of getting a top rank. There's offer alert. Every 24-month subscription will give away 4 months subscription free, which is valid for today. And with every 12-month subscription, we'll give away 3 months subscription free. Only a few hours are left out. And if you are talented enough, you try to write the combat. Combat is nothing but a live quiz competition where 20 questions will be asked, 60 minutes will be given, conducted this Sunday at 11 a.m. Separate paper will be designed for mechanical, civil, electrical, EC and CSIT, and 20% guaranteed scholarship will give away. And not only that, 500 lucky participants will also stand a chance to win all these gifts. And those who perform well, we are ready to give away rupees 4 crore as scholarship, including 100% scholarship or free subscription. And the good thing is, you need not pay anything to write this combat. The subscription is free. You can use the code KNR10 in order to enroll yourself. If you are having any doubt in your preparation journey, subscriptions or latest offers, you can contact our counselor. This is the number for the same. Unacademy Ask a Doubt feature here, through which you can ask unlimited number of doubts. You can ask 3 doubts at a time. And you can get the solution in your preferred language, and very easy to ask your doubt also. Just click, crop and submit. This super combo offer going on here. With every 2-year subscription, we give away 1-year subscription free for campus placement and IT jobs. With every 1-year subscription, we give away 6 months subscription free for campus placement and IT jobs. The rank predictor which is on, let me explain how rank predictor works. Just log in, go to GATE landing page and click on the rank predictor banner, select your stream, select your session and paste the URL, your rank will be displayed. These are the special class features here where you have interactive live classes, polls for the learners, raise the hand option. You never miss a class when the notification is on. You can download the lecture notes then and there. You can access anytime and anywhere. We are introducing community here through which you never miss any updates from your favorite educator. You can download notes and practice materials, and you can share the feedback directly with the educator via polls. As you know, every week we launch 8 to 9 new batches. These are the new batches dear. Resilience for GATE 2023 for electrical explained bilingual. All these are started on 16th of February dear. Resilience GATE 2023 for ECE explained bilingual. Ascent GATE 2024 for ECE explained bilingual. Ascent GATE 2024 for electrical explained bilingual. Evolve GATE 2023 for electrical explained bilingual. Evolve GATE 2023 for ECE explained bilingual. These are all the batches across all the other branches. For each one of them, you can use our team code KNR10. Not only that, you will get 10% off, but also the complete team support will be with you. Thank you for joining and all the best dear.